All right, so as I mentioned, I am going to go ahead and finish off problem 2 and problem 3 just to kind of show us what, give us a couple more examples. So for problem 2, we have y equals 2 cosine of 3x plus pi over 2. So the first thing we're going to do is we're going to pull the 3 out. Now the reason we do that is it allows us to see more clearly that our a is 2, our omega is 3, and our phase shift, phi over omega, is going to be, in this case, because it's going to be the opposite. So we're shifting it. Here we're adding pi over 6, so we're going to shift it negative pi over 6. And you'll see what this looks like actually when I graph it. So now that we have our amplitude, or we have our a, which means our amplitude is 2. We have our omega, which is 3, so our period is 2 pi over 3, and we have our phase shift. So we have all of the pieces that we need in order to graph this function. So we're going to start off. Our first column right here, highlighted in gold, is the regular special points, right? Same thing we always start off with: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, in our second column, we are going to do the same thing to our first column what we did to the period. In this case, we divided the period by omega, which is 3, so we're going to divide all of these by 3. 0 becomes 0, pi over 2 becomes pi over 6, 3 pi over 2 becomes 3 pi over 6, 2 pi becomes 2 pi over 3. Fantastic. Our final row, we're going to take the second row and shift it by our phase shift. So in this case, if we're shifting to the left, that is subtracting pi over 6. So 0 minus pi over 6 is negative pi over 6. Pi over 6 minus pi over 6 is 0. Another pi over 6, pi over 3, and pi over 2. So we can go in and graph these. So we're going to do pi over 6, negative pi over 6 about right here. And then we can do pi over 6 about right here, pi over 3 about right here. So let's look at our first point, 0. Cosine of 0 is normally 1, okay? So, but now that 0 has been shifted to 0, so it hasn't changed, but it's been shifted to negative pi over 6. So we have cosine of negative pi over 6, or once we plug pi over 6 into our equation, right, we'll get negative 1, we'll get positive 1, excuse me. But now, remember, our amplitude is 2. So I'm going to go ahead and write right here a 2, and it looks like this, right? All we did was we said, look, normally cosine of 0 is 1, but that is shifted to, that is, I guess, divided or shrunk to 0, so that doesn't change. And it's been shifted at negative pi over 6. So when we plug negative pi over 6 here, we get just 1, but now we have to take into account the amplitude, so it's 2. Now at 0, or excuse me, at pi over 2, cosine is normally 0, but that pi over 2 has become pi over 6, has become shifted over to 0. So we get right here. And similarly with pi has been transformed into pi over 3 and then shifted to pi over 6. So cosine at pi is normally negative 1, but now at pi over 6 it's going to be negative 2 because the amplitude. And same thing for pi over 3, we're back at 0, and at pi over 2 we are back at 1. So one thing I want you to notice is that we use the word shrink or compress quite literally, right? Normally this equation would look like, I'm going to draw this in green here. Let's pretend this is 1 and this is negative 1. This equation should look like this, and -1 right here, and then back to 1, which I put right here. Okay. So, wait, are these in the same spot? No. Let's put 1 right there. Okay. So this is what the equation should normally look like. So you should notice two things, right? I'll put this as normal cosine. So you should notice two things. The amplitude has stretched it, right? So it has been stretched vertically, right? It's taller and deeper, right, than the original. But similarly, it has compressed it. It is way smaller, right? Way shorter on the horizontal axis than the original. And that, again, is to be expected because we understand that this A out front, right, shrinks it or stretches it vertically, and this omega is going to stretch it or shrink it horizontally. So A vertically, omega horizontally. And so we can compare our graph in black to our normal expected graph in green, and we can see exactly that it has been stretched vertically and compressed horizontally. And that's what we expect. All right, so I've already done a little bit of work just to speed things up. But for number 3, we have y equals -3 sine 2x plus pi plus 2. So in this case, you should notice that this extra plus 2, this is our b. So let's go ahead and start writing what things are. So a is -3, and the amplitude is the absolute value, which is just 3. I went ahead and pulled the 2 out from the argument. So we have that our omega is 2. Our period is therefore just pi, right? 2 pi normal period and then divided by 2. Now our phase shift is pi over 2, but since we're adding pi over 2, we're going to shift it to the left pi over 2. And then we now have our b, which is just 2, and this means we're going to shift it vertically 2. Okay, so let's start with our special points, same as always. Now we're going to do to our special points what we did to our period, divide by omega, in this case divide everything by 2. So our second column is the first column divided by 2. So 0 goes to 0, pi over 2 to pi over 4, and so on and so forth. Our third column, however, we are going to subtract pi over 2, right? Then we're going to shift everything. And so 0 minus pi over 2 is negative pi over 2. Pi over 4 minus pi over 2 is pi over 4. Pi over 2 minus pi over 2 is 0. 3 pi over 4 minus pi over 2 is pi over 4. And then pi minus pi over 2 is pi over 2. So we now have our points. So let's go ahead and start playing with them. So we're going to say that this is a special point. Negative pi over 4 is a special point. 0 is a special point. And pi over 4 is a special point. And then pi over 2. All right, fantastic. So let's start. So sine of 0 is normally 0. But of course, that 0 has been, we divided that by 2 to get to 0, and then now we shift it. So now, at negative pi over 2, we are at 0. So we're right here. Similarly, at pi over 2, we're normally at 1, but that pi over 2 has been transformed to pi over 4, and then shifted to negative pi over 4. So that means that we would normally be at 1, but we multiply by 3 because our amplitude is 3, but then it's flipped. So let's go ahead and draw this as -3. And, or positive 3, or excuse me, yeah, positive 3 up here. and -3 down here. 1, 2, 3. Okay, so it looks like this. And normally at pi, we are back at 0, but that is pi over 2 and then 0. So we're at 0, 0. Pi over 4, which is the transformed version of 3 pi over 2, we will be at -1, right? Normally at 3 pi over 2, we're at -1, but because it's -3, we're going to flip it and then multiply it by 3. So we are at +3, and then at 2 pi, we're back at 0, and that has been transformed into pi over 2, so we're back at 0. So this is what it looks like without the +2. And now I did that on purpose because in my mind, the +2 kind of comes last. I think it's, you can do the +2 all at once if you want. That's perfectly fine. But I am going to make 2 graphs just to like help me out. So this is what it looks like. Now we notice, of course, that a normal sine graph looks like this. So we are, in fact, in a good place, right? It's been flipped upside down and then stretched by 3. So this does, in fact, look like what we expect. But now we are going to shift it up 2. So I'm going to make a 2 right here, and I'm going to do 1, 2. So this would be, call this -1. I'm going to just zoom in a little bit to help us out. So I'm going to graph everything, our new function, in purple. So we shift everything up 2. So this point becomes, this point is now sitting at the y value of 2. This point that was at -3 is now sitting at -1. This point that was sitting at 0 is now sitting at 2. This point that was sitting at 3 is now sitting at 5. And this point that is sitting at 0 is now sitting at 2. So our equation now looks like this. So this is our full equation. And this one is everything but b. So what, -3 sine of 2x plus pi. Yeah, excuse me, everything but the 2, everything but b. So that's what these equations look like, right? Again, we expect, because this 2 is greater than 1, and remember that things that are done in the argument are the opposite. So we divide it by 2, so we expect that it shrunk horizontally, which it did. Then we expect that it stretched vertically, which it did. And then we expect that it shifted because of this pi over 2, which it in fact did, right? Normally this point right here, the leftmost point should be sitting right at 0, but it's not. It's sitting at -pi over 2 because of this pi over 2 shift. And then it has been shifted vertically by 2. Normally we would expect that this top point would be sitting at 3, but because we have shifted it up by 2, it's sitting at 5. So that is what this equation looks like in its, or this graph looks like in its finality.